Hi everyone, I'm Krish, your LA, and today I'm going to walk through some game app problems and try to just go over concepts. So this video is the addition to what is in the lecture. It does not cover anything related to the lecture, but these are just a few extra problems which might help you in the course. Throughout the semester, I'm going to upload a few more of these regularly, but just keep an eye out for the announcement. Whenever I upload, I'll announce them. Mm, So let's get started. In this video, I'm going to go over two variable k maps, basic ones, three variable k maps, four variable k maps, and five variable k maps, and a few techniques which can make your solving of the k maps easier. From basics, if we go, k maps are used to get a minimal SOP or POS equation. We group ones if we want to find the SOP equation, and zeros if we want to find a POS equation. We have groups in like two or like one also, but like 2, 4, 8, 16, 32, and so on, depending on the number of variables you are having in your K map. Like a two variable K map, we can have these types of groups. In a three variable, these four variable, we can group up to like all 16, all the cells are same output. We can group the entire K map, but that's possible. Let's get started fast with the two variable K maps. I'll walk through the entire process of solving them, getting a SOP and POS equation, so it's easier to understand. When we group, we try to group all of the, like if we are grouping ones, we try to group all of the ones which are possible, and if we try to group zeros, we try to group all of the, we have to group all of the zeros or ones, and overlapping groups are permitted, we can do that also. um, the groups must have the maximum number of possible cells, like we can group in vertical or horizontal, these two methods, or square, depending on how the outputs are on the k map. With the first two variable k map here, if we start with SOP equation and see we have two ones over here, we the best thing when I see a two ones adjacent to each other is like I try to group them in a pair, vertically let's say, or horizontally. So here if I see for this group, which I'll say group 1, f is equal to 1, so f is equal to, and group 1, I see a is changing, like a is 0 for this for top cell and 1 for bottom cell, and it's the same for b is same for both of the cells. So when b is 1 and it's the same for SOP, when a variable is 1, we write it as it is. For POS, if it's 1, we write a complement version, but SOP, if it's 0, then we write a complement version for POS, and that's your equation for the entire table map. For POS, if we try to group zeros, we have a one vertical group, and we see B is 0 for both of them, so F is equal to B, because when POS B is 0, we have B, but if B is 1, we have B naught. Like this is for 1, this is for 0, and that's our equation. Now moving on to the next K map, we see all of the outputs are 1. We know by this F is equal to 1, but when we try to group them, like grouping all of them, and we see A and B, both of them are changing for each one of the cells. No variable is same for all of the cells. So we can say F is equal to 1. This can be your SOP. And POS, we cannot do it with K maps because there are no zeros, but we know this is a constant equation. Like F is always equal to 1, regardless of the variables. We got that. Now for the third K map, this we'll see here, we will need to overlap groups. So I'll start with POS first, and group 1, one or two of the zeros, I'll label this as 1, or let's say A. So I have A here, B here, F is equal to, so A, Now if I see B is the same for both of the cells and A changes, right? So B is 1, which means we'll have B over here. Now this is our A. For B, because it is product of sums, group B is either we do a single cell, or a better idea is to do two cells where we overlap, but it's fine, we are getting two cells. That's our goal, to get maximum number of zeros in one cell, one group. Now A is same for both of the cells, but B changes. B is 0 once and 1 other time. So A is, which is 1, so we write it as A naught, which is A naught B naught if I just rewrite it, and that's your POS. For SOP, we group a single one, which is we only have a 1, and we see A and B, both of them are zeros, so again it will be A naught B naught, and we see these both are same. Because it's a two variable K-map, it is possible that both of the SOP and POS can be same, but not all the time. Noted. Now moving on to three variable K-maps. Here we can group in 8s also sometimes, but mostly we'll see 4s. And yeah, for the first example, we see 4 cells over here, which easily we can group it, the entire 4 cells as one group. So we can identify here A and B changes for all 4 cells, like A is 0 for first two but like 1 for other two. B is also 1 for 2 and 0 for 2. So that's the variables which we cannot use in the equation when we try to write it for this first group, let's say A. But C is same and C is 1, so I'll just write down C here, which is and plus. Because it's product of sums, we have one product, we'll have another product here, and we'll sum them. Another group can be either a single cell, or we can just have a pair, a group of 2. Over here C changes for both of the cells, but A and B remain same, which is 1. So I can have AB like this, and that's your SOP equation. For POS, it will be product of sums. So if I have two groups, I'll have product of sums. To start with the first group and second group. First group, I can easily see this two adjacent ones, I can group them, and see here A is same for both of them, C is same for both cells, so I'll write A plus C. Because both of them are 0, they remain the same. The other good group is this 0, this cell, and this cell. Yes, we are able to group through the K-map on the other side also, and we get a group of 2, and we see that B is same for both of them and C is same, so again it will be C plus B, and that's your POS equation. For the second example now, this is a very similar example above one, where we go through the other side of the K-map. Like to group ones, I can group it like this, and write SOP as B is same for them, but C changes and A is also changing, so it's only going to be B. Now when I start with a SOP equation, we start grouping ones. Same drill, I see two vertical groups. I group this one, but we see these two cells are lacking, and we might have to group them like this. In this way, we have how many? 4 groups. But if I change the method a little bit to the grouping efficiently, we can group the second group horizontally and C, we can group the third group as through the K map. With this, we are only getting three groups of twos. Less groups are also better for a simpler K map equation, PSOP equation. So now let's try to make the equation. Same drill for, let's say, A, B, and C. A, we have C same for both of them, and also A and B same for both of them. So A is 0, so A naught, B is 1, so B, C is 1, so C. Plus, for group B, we see A is same for both of them, and C and D are same for both of them. A is 1, so A, then C naught and D. Same for group C, A, B, D naught. We'll follow the similar process for POS here, grouping zeros. The best way I can find here is zeros. This is a, there's this group, there's this group, and there's this group of four corners. Yeah, we are able to group four corners together, so it gets a bigger group of four, or just two corners which are adjacent to each other are also fine, not opposite, adjacent. For a 5 variable K map, yes. Here I'll try to make a SOP equation. If you see here, we have 5 variables, another variable E, which we need to have separate from the K map. So it's something like it's tagged on each other. This can be the top layer, this can be the bottom layer, or it's relative to how we look at it. Now I can here easily, I can see a group of 8 here, which is this. If we stack it and try to visualize, it becomes something like a cube. Over here in this group, if I see A is same for all of those 8 cells, C is also same for all of those 8 cells, but D, B, and E are changing, so we'll not use them. So it's A, C plus here I can see there's a group of 4 line right exactly here, which goes through the plane like E also, where A is same for all 4 of them. Also C and D are same for all 4 of them. So it's going to be A, A naught because A is 0, C naught, and D. Now if you guys observe here, if you observe here, if we had a group of, like in 4 variable K map, a group of 2 led me to a 3 variables in a group equation, but over here group of 4 leads me to 3 variables because we have one extra variable in the K map. That's why there is this similar like pattern. A large group which we have C large group, which is this just group of 2, where we'll see 4 variables because A, B, and C, D both, all 4 of them are same, which will be A naught, B naught, C, D naught.